posted online. Do we have a problem?
Only strong acids that like burn through things, right?
Yes. I mean, lemon juice is also an acid, but it doesn't burn through stuff.
Yeah.
That's why on the board it says strong acids are corrosive. Okay, then we look at the pH scale. The pH scale goes from 0 to 14, as I put there on the board. Anything that tastes with a pH between 0 and up to 7, not including 7, is an acid. It's classified as an acid. If it has a pH of 7, opikop 7, then it means it's neutral. And then obviously when we get to bases, you guys can probably predict bigger than 7 all the way to 14 will be a base. Yes. Water is neutral. Okay, and as we move further away from 7, the strength increases. So if something has a pH of 1 or 2, it will be a stronger acid than something with a pH of 5 or 6. Both of them will be acids. But the further away from neutral we move, the stronger the acid becomes. Okay. Everyone done with that slide? Good. I'll post the video again so you guys can go and watch it anyway. You guys don't need to know that. Then bases. Bases is basically the opposite. So they taste bitter. They often feel soapy. Yes?
And are you going to need to know the types of acids?
No. And on our pH scale, anything above 7 all the way to 14 is a base. Once again, not 7, from above 7.
Sorry, ma'am.
Put it away. I do not know why you're on your phone at this time. Okay, so let's just quickly focus on the pH scale. Let's say I have a substance with a pH of 5 and a pH of 2. What will both those substances be?
Acids.
Both of them will be acidic. So both of them will be acids. But the one with a pH of 2 will be a stronger acid than the one with a pH of 5. Okay. Now let's say I have two substances, one with a pH of 8 and one with a pH of 13. What will both of those be?
Bases.
Both of them will be bases. But do you guys understand that the one with a pH of 13 will be a stronger base than the one with a pH of 8? So you start in the middle. Going to the left, it's more acidic, and going to the right, it becomes more basic. Stronger base as far away as possible from 7. Stronger acid as far away from possible from 7. All of you with me? Okay. Yes. You guys can watch the video. Then in between them, we have acids on the one side, bases on the other side, and smack bam in the middle, we have neutral substances. The most common one, water. Specifically distilled water. So water in hot taps normally deviates a little bit, so it might be a bit below 7 or a bit above 7, but they're more or less 7.
Is that the last line?
No. Everyone happy with that?
Yes, ma'am.
Good. We might just get to the maybe. Okay, you guys don't need to write this down. This picture is in your book. Okay. So on this picture they show stomach acid, lemon, grapes, tomato, banana, milk. Okay. All of those are acids. Okay. But obviously stomach acid is a much stronger acid than milk. Then in the middle we have water with a pH of 7. Okay. And then from there we go bases. Eggs, baking soda, soap, detergent, all the way to oven cleaner or drain cleaner. So obviously if you have a nice cooked egg or a cup of drain cleaner, both of those are bases, but one of them is not safe for consumption, right? Because the further away we get from the middle of the pH scale, the more corrosive a substance becomes. Okay, so the more poisonous the base becomes and the more corrosive the acid becomes.
I mean, lemon is almost as dangerous as stomach acid.
Yeah, but it's not though.
Is there anything that's zero?
No. Yes, close to 0, not at 0. Okay. But this one is in your books. This is on page 94. But you guys understand, most important thing from this slide, you guys understand what the pH scale works like.
Yes, ma'am.
On the left-hand side of 7, we have our acids, and on the right-hand side of 7, we have our bases. Also, the further away you move from 7, the stronger the substance becomes. So it's an acid, and then it becomes a strong acid. If you're on that side, it's a base, and then it becomes a strong base as you move away from 7. Okay. Yes.
What's going to happen if you mix acid?
Right. Go.
That
No, you're not. Yes? Scale of numbers that indicate how acidic or basic a substance is.
How low is sulfuric acid, man?
Sorry?
How low is sulfuric acid?
Very low. It's one of those. Sulfuric acid is a very, very strong acid.
I mean, hydrochloric.
Hydrochloric acid also very strong. So also a very low pH. Okay. When you guys take science next year, and you continue to take science until grade 11, actually grade 12, then you're going to work more with the pH scale. So then you're going to start calculating the concentration of hydrogen ions. So you take the pH scale and you put it into there. But you don't need to do it this year.
No. No.
Yes.
How hard is science in grade 10?
It's pretty hard if you're not hardworking. If you work hard, then you'll be fine.
But you don't need to take iron. You take science. I would not take bio.
Okay, everyone happy? Can I carry on? Hi, guys. I want to get to the experiment.
What do they mention?
Write quicker. Okay.
Manage battery.
Those of you that's done, you can write down indicators. Battery is acid.
Is battery acid dangerous?
Very, very corrosive. The last thing we're going to talk about is indicators. In your books on page 94, you will see they have many different indicators listed there. For your test on Monday, we're just going to talk about 2 different ones. Then when your test is done, I'll come back and discuss the rest of them. Okay. Everyone done with this slide? Good. So you need to know what indicators are. Yes. Yes. You don't have to draw that picture. Just write the definition of an indicator. An indicator is a chemical that changes color when they come into contact with an acid and a base.
Done.
Done writing that?
Yeah.
Yo.
Oh, yeah. But it's like a textbook.
That's Lydia's.
Yeah.
It's fine. As long as you study as hard as Lydia
Yeah,
studies.
this-
No, don't
This
lie.
makes it so much easier.
Sure. But you haven't written it in your book.
Yeah.
No, he doesn't have one.
You don't have that. In your shoes.
Hey.
Yeah, I'm glad you stopped it, man. I would have made him cry now.
No, let's stop. Okay, so all of you have that. Chemicals that change color when they come into contact with an acid and a base. I told you guys you don't have to draw the picture. Okay, so you can write down for yourself. For now, we're only going to look at litmus, and the universal indicator. So there's litmus, and I'm going to show you the universal indicator now. Okay. Okay. Yes, quickly write that down in your books while I set up the